Thank you for attending today's webinar, Security Considerations for Virtualizing Cable Services, sponsored by Juniper Networks, with participating companies Comcast and Cox. Before we begin, I wanted to cover a few housekeeping items. On the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we do not answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. Towards the end of today's presentation, we'll ask for your feedback. A survey will pop open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Light Readings analyst Alan Bresnick. Alan?
Hi, thanks, Stephanie. Good day, everyone. Welcome to today's Light Reading webinar entitled Security Considerations for Virtualizing Cable Services. As Stephanie mentioned, my name is Alan Bresnick. I'm a contributing analyst at Heavy Reading, which is the research arm of Light Reading, and I will be your moderator today. Based outside Toronto, I specialize in the cable, video, and broadband technology markets. I've put together this webinar in conjunction with our sponsor, Juniper Networks, and our two guest cable operators, Comcast and Cox Communications. We have a provocative program for you today, focusing on the security aspects of virtualization. We'll explain where the virtualization movement stands today. We'll discuss the security concerns that cable operators and other service providers face with their existing architecture. We'll explain the new security issues raised by virtualizing the architecture, and we'll talk about how operators can overcome these security issues. So it should be a very interesting webinar, we think. Slide here talking about webinar logistics. Stephanie already went over most of them, but put a slide up there just to highlight a couple of things. Remember that we'll be able to download the slides by pressing the Additional Resources button, and at the end we will have an audience question and answer session. At that time you can take part in the Q&A session by asking questions at any time. Just type your questions in the Ask a Question text area. We'll also have one audience poll to gauge your views about security and virtualization. Okay. All right, so let's take a quick look at our three featured speakers today, who we'll hear from in, appropriately enough, virtual roundtable format today. Once I'm finished setting the context for today's discussion, our first speaker will be Wayne Chung. Wayne is Director of Product Marketing for SDN/NFV for Juniper. He joins us this morning from San Diego, bright and early. Next, we hear from Nagesh Niranjan. I promised I wouldn't say this wrong. Nandaraju. Sorry, Nagesh. Nagesh is Director of Network Architecture for Comcast. He joins us from Philadelphia. Our third speaker will be our old friend Jeff Finkelstein. Jeff is Executive Director of Network Strategy for Cox Communications. He joins us from Atlanta today. Now let's look at today's agenda. As usual, we have plenty to cover over the next 60 minutes. As you can see here, first we're going to talk about where NFV adoption stands right now among service providers and enterprises. We'll give a basic overview of the SDN and NFV architectures. We'll talk about why security should be front and center in all virtual network discussions. We'll spend a lot of time going over the security considerations for virtual architectures and how they differ or in addition to the security considerations for physical architectures. We'll talk about how to leverage virtual security to solve the problem of virtual architectures, the security problems that are raised by that. And we'll talk about monetizing your security infrastructure through managed security services. Okay, so lots to cover here. So let me jump right into it. Let's begin by taking a look at what some early pioneers in virtualization are realizing, the leading service providers that have gone into virtualization. We've seen a couple of early results that have been presented, one by Colt. Colt has talked about how they've lowered the total cost of operation by 41% since starting to virtualize their networks, and this graph on the left shows that. Well, AT&T has talked far and wide about how they've improved the provisioning cycle by nearly 100% through their efforts on virtualization, as the graph on the right shows you. So two very strong results from two of the first service providers that have ventured into virtualizing their architectures. Next, let's look at what's happening on the enterprise side. We know that enterprises are quickly accelerating their adoption of cloud services. And this graph from Juniper shows some of the results here. We talk about how over 3/4 of enterprises report meaningful adoption and believe more processes could be moved to the cloud. Nearly 100%, 91% talking about moving the software in 2014, and also we talk here about what SMBs are doing on the cloud services and how there's much greater interest in using cloud-based services and cloud-delivered services than there was before. So we're seeing it on both the enterprise side, and we're increasingly seeing it on the small business side as well. So this is what service providers' customers are interested in, which is why service providers need to be more interested in virtualization and cloud-based delivery of services. Not surprisingly, SDN and NFV spending are accelerating. This graph shows a lot of the numbers here. I won't go through all of them here, but what really stands out, one of the things that really stands out is that by 2018, the projections are just 3 years from now, that NFV and SPN spend will be over $10 billion, close to $11 billion according to this projection. And that another thing that really stands out to me is that SDN and NFV are expected to influence close to 80% of networking decisions associated with network revenue by the end of this decade, just 5 years from now. So there's clearly, even more than a movement, there's clearly a revolution going on here as service providers and enterprises, as service providers' customers, are all moving to virtualization. Okay, so given that context, let's look at what cable industry is doing. Cable industry is been widely considered to be a little bit behind on moving to virtualization, but there's actually a lot of activity going on, and our speakers here may actually differ from that premise, because there really is a lot going on, particularly by the two operators that are on this call, Cox and Comcast. A lot of major MSOs, including Cox and Comcast, are now exploring both SDN and NFV in their lab trials and in pilot field trials that maybe our speakers will get into a little bit here. There's been a number of RFIs and RFPs that have been quietly issued to vendors by MSOs looking for help from both equipment and software vendors. There was a greater initial interest in the cable industry in SDN, but NFV seems to be gathering momentum right now. Key thing that we're going to get into in this webinar, what this webinar is all about, is that virtualization raises some new security concerns with architecture, as well as exacerbating some of the existing security concerns with the cable architecture. So we're going to get into what the existing issues are, and we're going to talk about how virtualization changes those and raises some new issues. What's good going on for the cable industry is the Cable Lab seems to be leading the way on the research front in terms of both SDN and NFV, and is participating as a founding member, actually, of the OP-NFV project of the Linux Foundation. Okay, so now that I've set the context here, I'm going to move things past the baton over to Wayne Chung. Wayne, actually, I have one more slide. I'm sorry. We're going to talk about the revenue opportunities beyond connectivity. Lots of revenue opportunities here. This chart spells out what can be done on all sorts of different levels from cloud-based managed services. We're going to hear more about that on this webinar. Some of our speakers are going to talk about what they're looking to do with managed services and managed security services. But in general, cloud-based managed services facilitate access to new markets, to new services, and to new business models. We're seeing it happen on a bunch of different levels, and here are some of the reasons why. So you'll be able to go through this slide in more leisure when you download it later or when you look at the webinar later on. But for now, I am going to pass the baton over to Wayne Chung. Wayne, let's take a minute to look at the foundation for our discussion. What does a typical SDN-NFV-enabled architecture look like?
Okay, thank you, Alan.
Sure,
yeah,
good morning.
So let's start. Good morning. So let's start off, with a basic SDN architecture to just level set this conversation before we jump into the details.
Sure.
So the movement around this SDN architecture is really about a couple of things, right? It's a couple of themes specifically focused on separation and abstraction. And the result of this, and the key of this, is really to allow the service provider to create more agile, flexible infrastructure to therefore address the evolving demands of customers. And so with that, really, we kind of look at the separation of this into three specific layers: the infrastructure layer, the control layer, and the application layer. The infrastructure layer is where the predominant network devices would still reside. This is primarily where the forwarding plane of the data plane of the network would flow through in terms of constructing your network across the edge to the core to the customer prem even. But with that, the idea is to create that level of abstraction so that the control layer can be abstracted and more centralized. And with that, it requires the network devices to have an open level interface to be able to control that data plane. So whether you're trying to build things like EVPN or other types of networking services, that abstraction allows the SDN control layer to be able to formulate a viewpoint of that of how the network is constructed, and to be able to logically and programmatically introduce that control layer. So key elements of this will become focused on programmability, automation, so that you can build that level of network build out, but in a more centrally organized manner. And then very important is also that interface into the business application layer through open APIs, so that we interface with existing systems for business logic and so forth. Now, with this sort of deconstruction of this network and these layers, introduces obviously greater security risks that some are still very traditional and some will be new. So we'll be taking a look at the elements of, what does security mean in this new world with this sort of picture in mind. So moving with that trend is the NFV movement as well. So while we talk about software-defined networks and being able to construct networks in that sort of automated way, we also are now seeing, because of the virtualization capabilities of these network applications, we're seeing the movement towards services being built out in this sort of abstracted way as well. So where traditional capabilities, let's say, such as CDN or firewall or BRAS or a whole host of other types of applications that are listed here on the left, as we're able to abstract these from the network components and build this into virtualized infrastructure, this allows service providers to really roll out these new service and capabilities to customers in a much more optimal way, both from a business perspective, from a commercial model, to that also of accelerating the delivery of these network and security service capabilities out to the customer using standard x86-based hardware. But with that, with sort of the virtualization of these applications, it really means two things from a security standpoint. One is these applications now need to be secured themselves on that hypervisor in that virtualized infrastructure. So this imposes potentially new security boundaries and risk factors that we'll have to invest in to be able to protect this type of infrastructure. But secondarily, this NFV movement also allows for these type of services to be offered as a service. And what this allows for is great agility to roll out these capabilities in this managed service context. And this provides both the provider a great opportunity to roll out services in a more agile way, but also for the customers to be able to customize and get those type of services from the service provider in a much more rapid manner. So this NFV movement, combined with the SDN programmable network, is really sort of two main factors that we'll investigate from a security standpoint going to this webinar today.
Okay, thanks for those insights, Wayne. Appreciate it. Let's turn to our two cable operators here. Nagesh, how does the Comcast architecture align with these basic architectures?
Thanks, Alan. Thanks, Wayne, for setting up the stage here. So I think fundamentally, if you take a step back and look, right, what NFV is offering and SDN is offering is a fundamental way for us to rethink how we construct networking, right? And so the fact that we are able to think layered by layer, fundamental layers of services that we can add here gives us a bigger opportunity. So we are thinking right now for all our next-gen access networks or edge networks, we are thinking security as a fundamental layer where you have to take multiple contexts into and tie it up with the applications that are going through. And it sets up a very good stage for us to offer our next-gen services that are more secure for all the customers.
Okay, thanks, Nagesh. Jeff, let's bring you in here. Good morning.
Good morning.
Can you shed any insights on how Cox is approaching SDN and NFV from an architecture perspective?
Yeah, we've been having many discussions internally. We've done a number of internal proof of concepts. The one that we've put a lot of effort into, we ended up calling Athena, which sort of is described as an end-to-end virtualization architecture.
Right.
Which doesn't really deal with products, it deals with more philosophies. Whereas Nagesh said that using it to construct things, I think of it as we're using both SDN and NFV to deconstruct, that to break devices into their constituent parts. The things that have to be in hardware, we keep in hardware. The things that we can put into software, like the cognitive functions, route computations, quality, metrics, service flows, things like that. So as part of that, the virtualization and breaking things apart, you have to protect those interfaces. And there's multiple layers, which Wayne will get into later, that you have to really think through and think about at what level you want to protect as you pass through the deconstructed layers, which no longer line up so nicely like they do today in a ISO type model.
I think you described this in a column for us earlier. You're splitting everything up into little like kids blocks, and then you're reassembling the blocks and seeing how they go together again.
Yeah, I mean, it's what are the key functions? I mean, none of this stuff is new. This has been around a long time. The concept of from monolithic entities, we then back in the days of the punch cards, into the days of writing big monster programs, into sub-programs, creating threads, creating micro threads, creating even smaller modules, and being able to have each one of those live in its own secured environment and define the gazintas and the gazaltas.
Got it. Thanks, Jeff. So let's move on to the security considerations. So I'll turn back to Nagesh. Nagesh, so what's changed from a security perspective? Why can't we simply keep doing things the way we have before? Nagesh?
Sorry, I was on mute.
That always happens.
Great question. If you look at the traditional network architecture, right, be it telco or cable, so typically how we design, security is always an aftermath, right? So it's an afterthought after you design applications. So there are these networks that are transporting bits and applications that are running on server infrastructure, and they are completely separated, right? So they are, and then you protect your application space and you shield your network with firewalls. So, the traditional trend is you group all these applications together and you build a fortress around, and then you try to provide access control lists or some sort of monitoring, and you tend to build that wall so high that you can prevent attacks.
Right.
But what has changed now with the whole NFV and SDN concepts you're separating out these layers and you're breaking them apart, as Jeff has alluded to, right? So we are breaking the applications into multiple smaller components. We are breaking the network into multiple digestible components. And by that, what we get is because we have to manage so many of those small components, we introduce the layer of network programmability, right? So that's almost a blessing in disguise, right? Is we are able to now programmatically control these devices, programmatically manage these devices, and programmatically account for the activities or the applications that are being accessed across the board, across the network. So we have much more granular control of these different devices and applications. So because we are separating out the control plane out of the network layer, so now we can add almost as a fundamental layer of security that keeps track of which applications is being accessed by whom, when, and how long, what kind of actions have been performed. So we have the capability of adding that, building into the applications or the fundamental network layer itself. And if we go a step further, right, in an NFV world, purely all the applications are being virtualized. The network functions are virtualized on top of hypervisor. Hypervisor maintains a context that's almost, we have not seen that in the past, is it has the global context of what packets are going through, what applications are running, and we can couple that with more intelligence from a user space to provide more intelligent decisions and enforcements. So at the same time, if you look at applications like carrier-grade NAT, all these applications can take advantage of those fundamental hooks in the platform. Mm-hmm. And if we advance to the next slide here. So, and then the other change besides the NFV movement is we have to think about the enterprises and the small, medium businesses and the movement towards cloud. Right. Traditionally, if you look in the left-hand side of this diagram here, so as I said, right, most of the traditional enterprise architectures also used to group applications together, build fortress around those applications, and tightly control the policies to access those applications. Now, so most enterprises are now moving towards virtualized public or private clouds. And that means one of the bigger advantages of cloud is this whole load balancing and always available, redundant, right? So that means natural definition is now you're spreading the applications across multiple data centers. So that means you don't have a centralized place where you can manage policies that affect that particular application group. The applications can be spread out across 3 or 5 data centers. And the firewalls that were protecting one group of applications are now spread across. So that introduces the programmability requirements for controlling these applications. The other change that's happening is within the cloud. Now, if you consider a public cloud like Amazon's public cloud, these applications are not native of that particular enterprise, right, which is hosting the cloud. So they may have a firewall, but the end users or the enterprises are creating their own virtual private cloud on top of it. And they would have distributed firewalls to protect their application groups. Mm-hmm. So all these changes are forcing us to rethink how we provide security. How do you manage it across multiple distributed endpoints and multiple distributed groups of applications?
Wow, this sounds like splitting the atom, Nagesh.
It's almost like that. I mean, but the good thing that's happening here, right? So if you think of generally like a networking, you don't get greenfield opportunities very often. So the NFV, to me, almost it's a very great opportunity for us to rethink how we design applications and how do we design applications that are very secure. You protect the data that's passing through, you protect the data that's in rest, and then you also protect the applications that is acting on the data. So, I think it's a really great opportunity for us to engage and to rethink all the different problems that we've been solving in one way or the other to have a common uniform platform And we at Comcast are actually investigating ways where we can build this almost as a fundamental layer, right, and then expose the different hooks for the applications that are onboarded on top of the infrastructure to take advantage of that those hooks.
Well, so it really allows you to start all over again if you want to. Jeff, anything you want to add to all that? I think we have Jeff on mute too.
No, I was looking at my notes from what Nagesh was saying. So I'll break it down maybe into 5 key areas.
Okay.
Right? And kind of the basics. One is you got to start with the physical security. So make sure that just from the beginnings, protect the hardware that's there. Secondly, you have to start with the host operating system, right? And the hypervisors that run on top of that,
right.
Running that. That's got to be protected, whether you're using a secure Linux or whatever you're using. Just it's got to be. You got to start with known bases. If you don't secure the physical and the base operating system, nothing beyond that is going to be secure.
Right.
Secondly, you got to secure the communications lines, or thirdly, maybe, so that as you communicate between VMs, right, you've got to make sure that is secured. So whether you're doing encryption over the TCP links or whatever that is, that's got to be rock solid.
Right.
So SSH, SSL, IPsec, all of that, has to be part and parcel. You can't think that it's simple just because it's virtual.
Right.
So then you got to protect the communication between the guest, and whether you're using containers or VMs or whatever you want to do. But you've got to make sure that, because everybody's kind of using Open vSwitch for moving the traffic around. So within each of these environments, you got to be sure that that's secured. So you got, again, it has to be from the basics, physical, on up through the layers. And then finally, you've got to get up into the application layer and secure at the application layer. Whether you're using some form of checksums, sentinels, whatever, to make sure that everything along the way is secured. You've got to take every precaution possible because of the environment and the fact that a lot of it is being replicated. One bad thing is going to spread very quickly. So you've got to kind of go through this whole stack and start from the beginning with it, like Nagesh said. The 2 things we typically put last are security and training.
Right.
And in this case, we need to start with those up front.
So one bad apple does spoil a whole bunch here. So definitely a lot to think about there. Thanks, guys. Wayne, let's turn back to you. How about threats? Please help us, audience, understand what the traditional threats look like. I'm assuming they haven't changed at all.
Yeah. And Jeff and Nagesh, thank you for that as well, because I think the security as an afterthought, I'll go through some things here that really kind of make us rethink that a little bit, because much of this is going to be about policies and procedures as well as security, because they all sort of fold together in some shape or form.
Right.
So what I'll cover here really are some traditional security risks. Obviously, these will not be all of them, but this really gives you sort of a sampling of how some of these traditional security risks impact the virtual environments in a different way. So let's walk through a couple of these. Targeted malware, right? Malwares, as we all know, is an ever-growing type of thing that we have to keep the databases fresh and keep our ability to thwart these threats always up to date. So virtual machines really just adds a new type of malware threat system that we'll have to put in place to prevent those dedicated malicious malware attacks that are targeted towards virtual machines, really kind of creating an in-network attack scenario that might take over some of these OS resources. And they become very hard to pinpoint once you once you let those type of threats into the system. So by introducing virtual machines and this whole virtualization model in here, you'll have to expand the type of malwares that you have traditionally looked at. Somewhere theft drive and data loss, those are some other things. But let's also take a look at a couple other areas around audit scope creep. This becomes a bit more of some procedural type of things that you'll need to keep in mind, right? Whether you're talking about healthcare with HIPAA or PCI with retail or SOX compliance, there's going to be a range of these type of situations that that basically will introduce new type of compliancy on those virtual machines. So think about a virtual machine that you've carved up now, right? And you've partitioned that machine against multiple workloads. So that potentially means that x86 machine that was dedicated maybe to a central function before, maybe is partitioned up to multiple usages. And because of that introduction of a certain workload on a machine, that potentially puts the whole machine into the audit scope. And this is what we mean by scope creep, is that you may unintentionally have introduced more additional devices into that regulatory compliance audit scope. The other is around missing security patches and updates, meaning, with virtualization, we get great flexibility to move one virtual machine to another virtual machine and shift workloads around. But because you're moving these things around so dynamically and in real-time fashion, that may mean that certain infrastructure isn't in place because a machine that you moved it to previously may have had that security patch, where the machine that you moved it to may not. So having that proper policy and procedure in place so that you make sure that wherever you're shifting things around, the security patches and updates are always current is really an important element. And then the last is around some reliance on traditional barriers. Again, the whole notion of virtualization is to be able to shift workloads around. But by doing that, you may put things into new subnets or new segments of the network that may not have been protected by the traditional firewalls. So this model that Nagesh had showed, where you had that centralized model with centralized firewalls, may introduce potentially challenges to keep up to date with those security policies that you put to keep up with the agility of the virtualized world. So these are only really a sampling of some of them, but it gives you a perspective of how they differ in a virtualized world.
Thanks, Wayne. I'm sure people are thrilled to hear about all these things.
Yeah. Hopefully it sort of lends sort of a new light to it, right? And with this slide, what we'll cover off maybe some new risks, new security risks that really didn't exist maybe in a physical world, but now are sort of pertinent in a virtualized environment. So the first is really around accelerated provisioning. The speed at which we're moving, the whole notion of SDN and NFV is fast to market, being able to roll things out at the pace that customers are demanding today. But because of that, if we don't have the right automation in place, if we don't have the right security principles applied to the provisioning model, this could potentially open up lots of holes and lots of risks into the network that were unexpected before. So this is kind of what I was saying earlier. You have to introduce the processes and policies in place in your system of how you deliver these services, so that security is always top of mind at the forefront of it. Mixed trust workloads. Again, moving sort of workloads onto machines where on a specific hardware, you may have a workload that is very secure in nature, and then another workload that's not very secure in nature. But because you're mixing the two together, it puts that whole host machine potentially at the at a higher security risk factor than before.
Right.
And so moving really to the right, if you don't have the security staff that wasn't, so maybe non-traditional security people who are managing that machine that's now being placed with a high security element on that machine, it puts that non-traditional security staff sort of, in a bind, right? Because they weren't really used to managing that higher security threat level. So, having that type of policy again in place so that if you do mix workloads together, that you understand which staff has which type of role access into a certain machine so that you maintain that security level. VM migrations and maintenance. Once you migrate things, once you shift things around, again, it potentially puts things at risk. But Jeff touched upon this as well, the hypervisor integrity concerns. So,
right.
From bottoms up, from the BIOS level to the operating system, up to that virtual machine, all those different layers have to be protected. So, BIOS, for example, is one that if there was, an alien BIOS that was sort of introduced onto that machine, that would be incredibly hard to be able to diagnose. So having, again, policies in place where you have BIOS checks and so forth to maintain that security of the machine is critical. And lastly is around visibility and control of your network. Having the network polling as to what's going on across all of your different devices in a centralized management system to be able to look through all of that and keep everything up to date is also very key in this. So some new considerations to really look at here.
So operators need to balance both the new security considerations as well as the existing security considerations.
Absolutely.
That may be exacerbated by virtualization. So lots to consider here. Thanks, Wayne. Jeff, Nagesh, any additional thoughts on this issue?
Yeah.
No, I thought Wayne covered it nicely.
Yeah, it was very comprehensive. Nagesh, anything?
Yeah. Yeah. If I were to just summarize, he covered a pretty detailed analysis of this, right? So to just summarize, take a step back, we're seeing a blurring line between networking and applications, right? And what I mean by applications is because we are trying to virtualize the network functions, so they are treated as an application. So we get two areas of threats, right? One is the traditional threats in an application model, and then you also have a threats from a networking side of it, right? When I talk about applications, it's like memory leakage using shared memories or interrupt takeovers or some similar sorts of those application threats, right? And then when what generally network operators are more used to is protecting the network threats. That's like a DDoS attacks and getting into the networks through backdoors. So those are the issues, right? So now we are seeing such a blurred line between both these. So we need to be cognizant of what are the new hybrid attacks that are possible. And we also need to retrain some of our folks to think of how these applications could pose threat to your traditional network functions. So yeah, so it's definitely a changing landscape, and as Wayne alluded, so we are already having some of these solutions thought through from this angle.
Okay, thanks, Nagesh. So definitely a lot to consider here. So Wayne, now that we've scared the hell out of people, what are some potential solutions? How do we go about securing the virtual infrastructure and ensuring that the network user has the same quality experience and protection, whether that traffic is running over a virtual network or a physical network?
Yeah, so let's cover off some of those here. So
okay.
let's juxtapose two scenarios here. Nagesh kind of showed this up front here around scenario one, which is a centralized firewall to protect really a series of host machines with lots of virtual machines sort of running within it, right? This imposes not only high performance to that centralized firewall, but introduces really granular level controls into that centralized firewall, which really could explode the configuration complexity. It could explode the how you debug, how you upgrade that firewall. and potentially taking down a lot of components along the way. So, there definitely is a role for a centralized firewall in protecting a range of host machines and virtual machines, but we have to look at it really sort of maybe with a different lens. The other element of it is if you look at sort of the routing methodologies within the data center, between virtual machines. So here it's shown really is between a database and an application virtual machine. They need to communicate with each other. But each time they communicate with each other, there might be specific, demarcation points, right? And so with that, this hairpinning effect potentially occurs back to that centralized firewall, imposing an explosion of, n by n time sort of magnitude of traffic onto that particular firewall that they never was really expecting. And so really this kind of imposes a huge workload onto that centralized firewall. Let's take a look on the right to juxtapose this. Another way to look at this is that centralized firewall was really kind of to protect inside out and potentially a little bit of outside or outside in and maybe a little bit of inside out type of traffic. But it's tailored to high traffic workloads that are very specific in nature, right, to protect that sort of entry point into the data center.
Right.
But now that we see workloads inside the data center that need to communicate with each other, a blend of that with sort of a virtual firewall or a virtual appliance to protect sort of that farm of appliances or that farm of virtual machines becomes much more granular in nature, much more pinpoint in nature to protect against that specific application set. So by blending this together, that removes some of those complexities that and that overload that you have on that centralized firewall. And in a sense, through these virtual firewalls, creates micro perimeters for you to be able to more easily manage and upgrade as well, specific sort of zones within your data center. So this blended model becomes a much more elegant way to sort of manage through this a bit. Excuse me. The next slide here really talks about how kind of extending upon that sort of blended world. How do we look at a virtual appliance versus how do we look at a physical appliance?
Right.
First and foremost, feature parity between virtual and physical should always be equal, so that I don't have to worry about, I deployed a virtual appliance. They don't quite have the same feature set as at my physical. I can't quite do the same thing. So that's that first and foremost is kind of the first thing you want to look at. Beyond that, really, the virtual appliance is installed on top of a hypervisor. It really can reside anywhere within a virtual environment because of the central orchestration through the SDN controller.
Right.
It will support less performance than a physical hardware. That's what custom silicon is built for, but it does give that sort of micro perimeter level, protection of the application zone. Juxtaposed really on the right, physical hardware, standalone piece of hardware, typically sits within a fixed location of the network. So if you need to move workloads around, physical equipment like this probably isn't the best place to move along with those applications. It's typically blind to the traffic running in the virtual world between the different application zones and the virtual machines. And it creates that sort of hard perimeter to the edge of the outside world. That's the way we see sort of that blend of the best of this physical and virtual together.
Thanks, Wayne. Really interesting. So, Jeff and Nagesh, do you agree? Do you think we can really get to a point where virtual and physical solutions can provide seamlessly identical capabilities?
Yeah, seamless is an interesting word. We can't think of things the way we've always thought of them. So we have to have this different way of approaching it.
Right.
And I think Wayne's hitting upon it very well in that We have to break things apart into their constituent parts. We have to protect unlike we've ever protected before.
Right.
And that by making it just part and parcel of everything we do in the virtual world, we have a better chance at avoiding some of the lessons that we've learned the hard way over the years from our traditional legacy deployments.
Okay, thanks, Jeff. Nagesh, can we get to that point?
Yeah, I think so. I think the fundamental thing, Ilan, is for us as application developers or network architects, I think we need to stress more on the requirements of thinking through the different security threat vectors and designing the applications or the networks to sort of address these issues. So unless we prioritize that, it may take more time than what's possible, right? So, but I think I'm totally with Wayne and Jeff here. So it takes time, but it's doable.
Okay, so we have a consensus. Thanks, guys.
Yeah. Well, I think the one extra point I want to make is
Sure.
that this is a great opportunity to do it better. And if all we achieve is parity with what we've done today, we've missed a great opportunity. We need to set a higher bar for ourselves and for those that we work with. I mean, from our security folks, getting them involved early on, because they just think about these things way different than the rest of us. We need to take advantage of it. So set the bar higher than where we are.
And take the advantage of the opportunity to start from scratch again and design your networks better than they were before.
Design your virtual networks better than your physical, yes.
Right, okay. Thanks. So we've talked a lot about how to protect the virtual architecture, but how do we handle the migration of data and applications to the cloud? Wayne, you want to tackle that?
Yeah, Alan, thanks. So really, if we look at the way that these networks are constructed, right? At that bottom layer, we've shown physical gateways, so hardware-oriented elements, and we've got virtual elements in the sense of vRouters, routing over into the hypervisors where your applications, databases, and whatnot, and services would reside. And up at the top, really, you have your control layer, SDN controller with Contrail, and orchestrators. So if you sort of break apart that software architecture in this way, there's probably three very specific things which I would sort of call our attention to from protecting that infrastructure. One is around roles. As we talked about, right, we're going to have people very highly focused on security, to people maybe just concerned about their applications, to that of people who are dealing with regulatory implications, right? So a key to this is aligning to a standard space approach with Keystone through OpenStack in terms of one is around role-based access controls. Who has access to what in the network based on authentication, and based on that, we apply certain policies to those users of what they can access, what they can configure, to the APIs even, so that with version 3 of the API of Keystone, there are granular controls for each call method into the APIs. So once you authenticate into the system under a certain role, you're only going to be able to be given certain access to certain call methods. And that will limit, the non-security structured staff from preventing them from doing certain things that they really shouldn't be, to advanced AAA methods that really gives you much more granular control. So roles in general is going to be a really big area. Okay. Now that we have really that separation of the config plane and the data plane, we also need to look at encrypting the communication channels between that through MD5 to XMPP or SSL, TLS, the authentication of that communication channel, again, with the roles-based sort of association to it, becomes very important to both connect to the physical and the virtual, so to the V routers as well as to the physical gateways. And then when we are creating sort of that routing protocol network, I mean, this isn't anything new to authenticating the BGP peers, but for all the virtual devices, the V routers that connect into that BGP peer, it needs to also be able to communicate within an authenticated manner. And then lastly, really, if we move down to the data plane, having the security policies between the multi-tenancy elements of it. So when we exit, in the virtual world, it's very easy to get lost between where the demarcation zones are. So understanding where those are, having the policies between them, and of course, on the data plane level, having encrypted tunnels through SSL or others is also of great importance. So really, roles, config plane, data plane, that's really kind of the thinking here in terms of that infrastructure. Let me just jump ahead here. Now, I talked about sort of that separation of the logical and physical. So when you start to build this in virtual machines down at the physical layer, within a certain host or hypervisor, we could be entertaining multi-tenant applications across them. And so what that means is when one virtual machine needs to connect to another virtual machine, but they're really intended to be across virtual networks, we need to apply the policies through the V router as they're intended to be across different segmented networks. So because of that, on that V router itself, it needs to have a security policy in place, like a firewall, so that when, let's say, G1 wants to route to B1, as an example, they're in different segmented zones. So the policy between that V router needs to be in place to enforce the rule sets. And but versus if it was between G1 and G2, then we should be fine to route without the policy in place. So think about that logical and physical separation as you go through it.
Okay, thanks.
So I'll touch upon two more here quickly, and we'll get to the Q&As here. This opens up really the door, right? As these workloads shift into the cloud, with virtualization of more and more of these components, and with security being able to be applied in this manner, we open up really a sort of an open world of dynamic service chains. And this allows us to address and accommodate the requirements from, let's say, within an enterprise, the different departments, from human resources to finances to engineering. They're going to all have different workloads. Through this virtualized model, we can create custom service chains now to really address those workloads that are specific to that user base. And with that, we really open the door for a chance to turn this into not only within an enterprise and looking at the multi-departments, from an operator perspective, they can utilize these service chains and create customized managed services in the cloud with sort of a host of routing capabilities as well as a suite of managed security services that they can offer in this virtual way through NFV. And we feel that this really kind of opens the door potentially for a wide range of potential applications in the world today. So with that, Alan, I'll pass that back to you.
Okay, very interesting, Wayne. Thanks for running us through all that. As the two operators on the panel, I want to give Jeff and Nagesh the last word. Jeff or Nagesh, anything you want to add to what Wayne had to talk about? Wayne had to say?
No, I think good. In the interest of time, we can cut short. But basically, I believe we as an industry have a very great opportunity to change and end customers' view of security. I think we could get started in thinking more natively supported security for all the applications.
Okay, Jeff. Thanks, Nagesh. Jeff, do you want to have the last word on this?
I think that when it comes to security in this particular context, right, you got to think outside the box. And as one of our VPs says, think outside the box, but never forget that there is a box.
Don't forget about the box. Okay. Thanks very much, guys. We were going to do a poll question, but for the sake of time, I think we're going to go straight to the audience questions. And also, we'll probably go a few minutes past the top of the hour. So stick with us, and we'll try to get to as many of your questions as possible. So let's go to the first question we have here. What would you say, this looks like it's for Wayne, what would you say is the most important feature or capability of the virtual security solution that you're talking about?
Well, that's a tough one to answer just because to pinpoint one of them as the most important would probably do this at the service. I think the most important thing I would stress is kind of back to what Nagesh and Jeff have said is put security up front, right? Look at it holistically from a process, from a procedural standpoint. Put the right architecture in place that has a blend of physical and virtual together that addresses the workloads that are of importance to you, and applying those practices in place. And then, and then also the things I've talked about in terms of how a virtual world implements a physical world and understanding those demarcation points.
Right.
Making sure that as one virtual machine exits to talk to another virtual machine that you don't forget about the policies that need to be in place amongst them, and having that the capability set in your virtualized architecture to be able to address that is, I think, a very, very big factor.
Okay.
But really, it's to look at security holistically.
Okay. Thanks, Wayne. Let's move on to the next question. This one's a fun one. Is SDN and NFV the nail in the coffin on traditional private networks? That is, do carrier-based solutions outperform private enterprise architectures? Who wants to tackle that one?
Well, I'll take a swing at it since you're locked over the plate.
Thanks.
So I think there's always going to be a place for hardware, right? No matter how much software has ever been written, it's never created a single photon.
Okay.
So you still have to have something that runs down at line rate.
Right.
Now, if you're talking about upward network layers, there are some things that obviously can go into software. But I don't, my own take is that the biggest, or one of the biggest mistakes we could make is starting off with the mindset that we're going to replace everything with something new. Because this is a long-term exercise for us to get to virtualizing network functions.
Right.
And there's going to be some things that are going to be logical, and we talked about this last week at the Vision 2020. And the question I ask is, it's not what do we virtualize, it's what we don't virtualize. Because we need to be very careful how we take things that are functioning today and providing a great experience for our users and try to make it simpler in some ways, which in the end may actually cost us customer experience.
Okay, thanks, Jeff. We're going to take a couple more questions, but I just want to let you know that I put a survey link, survey slide up on your screens. So please click on this link and fill out the survey and let us know what you liked and didn't like about this webinar and what you'd like us to cover in the future. And while you're doing that, we'll move on to our next question. This one looks like it's for Wayne. Wayne, how do you compare the total cost of security in virtual versus physical networks? Is it apples and oranges or apples and apples?
Yeah, that's a question that's asked all the time, and people think that because you're virtualizing something, everything's going to be instantly cheaper. So the key is to look at this over time, from my opinion, right? Because the first time you go through and implement a virtualized service or offering, you're not going to immediately see the benefits, because you have to look at the total cost from an operation standpoint, from a training standpoint, from a CapEx and management software perspective. So the first round through it, you're probably going to have a fairly high cost in terms of getting that enabled. The benefits of this is going to be over time, where now you've built up those processes and procedures to rapidly roll out new services. So when you bring up service number 2, it's going to be easier and faster. When you bring up 3 and 4, that's going to be even faster. So over time, you'll see the benefits of that investment. And you know, with the new type of models for consumption, you know, really now we're looking at on-demand models that better align with customer expectations for, you know, how they purchase things. So, right, you know, we'll be able to better align commercially to the way customers are demanding for things. So, you know, we could probably spend a whole another hour or two talking about just this topic, but I just don't want people to think virtual is instantaneously going to translate to cheaper. Right? That's not going to happen initially. It's a long-term investment.
Well, maybe that'll be another segment in the 12-part series that we're going to do with Juniper on security and virtualization. Private joke, sorry. How does the group view security IPsec on the CPE with virtualization? How do you do virtualize the CPE and keep them secure?
Well, and when we drew out the Athena architecture, part of it dealt with encrypting that tunnel, right? Or more appropriately, maybe it should be the channel between the virtual CPE and the cloud itself.
Right.
And it kind of strikes at the heart of some of the discussions, and it's what do you virtualize, what you don't, right? If you put where you terminate the tunnels, the IPsec tunnels, GRE, you know, L2TP, whatever you want to use, think of it more as an encapsulation in the cloud, and you virtualize that router gateway function and terminate it there. You've protected it across the entire physical link. So I think that's just the core essence in what we're doing.
Got it. Thanks, Jeff.
And Ellen, I'll just add one point there. I'll put a quick plug in here for a product that we have called the NFX 250, which is specifically intended for this, which is virtualize a CPE box that allows, built on x86, that allows you to put virtualized network functions at the CPE itself. And so whether it be for things like IPsec, building up those encrypt tunnels, whether it's moving certain VNF workloads onto the customer prem because policies dictated that or compliancy dictated that, it's a new box that we have to specifically distribute virtual net functions all the way out to the CPE if necessary.
Thanks, Wayne. Okay. Take another question here. Let's get in as many as we can. We've got a lot coming in. If functions are now moved away from a physical device at a remote branch, how does that device or branch have assurance that the function was actually executed?
That's a good question, Elan. Fundamentally, I mean, if you look at it, right, so it's what's changing is you have a device, it's in a remote location, and you need to be ensured that that device is hooked to the right network. It's a trusted device. Once you know that it's a trusted device, you should be able to build some hooks into the system to ensure that whatever you're executing is the right image that's running there on that remote device. And it's providing the right telemetry to give the insights to the operator remotely that these are the applications running and these are the inputs and outputs going on to it.
Okay, thanks, Nagesh. We'll make this the last question, and I apologize for any questions that don't get answered here, but we'll be sending the questions to our speakers, and they'll be able to respond by email later on. Last question, do you anticipate major changes in virtualizations for security on OSS applications? Sounds like a Wayne question, but anybody who wants to chime in on that? Is this going to change the way operators have to do OSS?
Yeah, so I'll take a stab here with that. I mean, OSS, I think we have both, existing OSS applications and potentially new OSS applications that you might roll out with this. So, they need to definitely follow along some of the principles we talked about with the roles-based access and so forth, aligning with the Keystone APIs for the call methods. They'll also need to sort of understand sort of the workflows that we're building in the virtualized infrastructure, and keeping sort of up with those. Integration with the Nano layer, so whether that be with the management and orchestration thing, as Etsy's defined it, at the orchestration layer, and then integrate that with the billing and whatever other systems we talked about with OSS. But from a security standpoint, yeah, it's really kind of following that shift of workload. So the big thing we talked about was, things are going to move tremendously faster at a pace, that we didn't see in the physical world. So the OSS application will need to be able to keep up with those changing dynamics, whether it's feature-based, whether it's policy-based, whether it's bigger than that. Newer OSS applications are going to be built with that more in mind, but moving into the existing systems, that's where that integration will be, we'll have to keep a closer eye on that.
Okay, thanks, Wayne. Well, I'm afraid that we've run out of time, but we'll be doing more webinars on virtualization and security and other issues, and we also will be addressing this at our conference coming up on March 10th in Denver, Cable Next Gen Technologies and Strategies, that I hope you can all attend. So I want to thank everyone out there for attending, and I want to thank our three main speakers, Wayne Chung of Juniper, Nagesh Nandiraju of Comcast, and Jeff Finkelstein of Cox for their thoughts and insights today. Let's give them all some warm virtual props. This webinar will be archived on the Light Reading website by the end of the week. Within the next 24 to 48 hours, you should receive a personalized follow-up email with details and a link to today's presentation on demand. So feel free to review the webinar whenever you'd like over the next 12 months. This webinar is copyright 2015 by Light Reading LLC. The presentation materials are owned or copyrighted by Light Reading, Comcast, Cox Communications, and Juniper Networks. These companies and their speakers are solely responsible for their content and their opinions. On behalf of Light Reading and our three sponsors and presenters, thanks very much for tuning in today. Take care, everybody, and happy holidays.